Okay, so today we're going to talk about simplest radical form. You may or may not have noticed that math seems to be a little obsessed with writing things as simply as possible. When you learned fractions, you talked about writing them in lowest terms. When we did algebra, we talked about collecting like terms to write our expressions as simply as possible. Radical form is no different. There is a way to write radicals as simply as possible, and that's what we're going to look at in this video. So, a radical is written in simplest form when the number that's under the radical sign is the smallest possible integer. So we're always wanting the smallest possible integer under the radical sign. I'm sure you're thinking, well, how do you change what's under there? That doesn't kind of make any sense. Just give me a minute. So to do this, you search for the largest perfect square that is a factor of the number under the radical sign. So for example, if you had, say, root 20, to write that in simplest radical form, you want to find the perfect square, the largest perfect square that's a factor of 20. Okay, so if you think of 20, factors of 20 are 1, 2, 4, 5, 10, and 20. So which one of those, if any, is a perfect square? And then you look for the one that's the largest perfect square. Well, 4 is a perfect square. 2 times 2 will give you 4. So that's what you're looking for. So in order to be able to find those, you may find it helpful to keep a little list, either down the margin of your page or maybe at the top or something like that, of sort of, the smallest-ish perfect squares. So I've made a list here that goes from 1, which would be 1 times 1, all the way to 169, which is 13 times 13. Some of you may not need to do this, but even I find it helpful just to have that list there so you can double check it against the list of factors for the number you're looking at. Okay, so how does it work? Well, let's look at a couple of examples. Root 8. Remember I said it was handy to have that list of perfect squares down the side of your page somewhere? I'm going to put it down the side of this slide so you can kind of see. So we've got 1, 2 times 2, 4, 3 times 3, 9, 4 times 4, 16, 5 times 5, 25, then we've got 36, then we've got 49, then we've got 64, 81, and we'll go as far as 100. That should be enough. Well, it's more than enough to do the square root of 8. So we'll start there. So we're looking at the number that's under the radical sign, and we're trying to find the largest perfect square that is a factor of 8. So you've got kind of two choices. You can write out the factors of 8, and then pick out the one that's the largest perfect square. So that would be 4. Or you can go to your list of perfect squares, find where 8 would be, so in between the 4 and the 9, and then work your way backwards and see if any of those are factors of the number in question. So in the same way that we found 4 off our list of factors, 4 we can find off our list of perfect squares as well. So we go back over and we're going to rewrite the 8 underneath our curly-ish looking square root sign as 4, let's just scratch that out and do this again. So square root of 4 times 2. It's really important to write that perfect square first, and you'll see why in a minute. So if you think backwards, that is the same as saying the square root of 4 times the square root of 2, because remember when we were multiplying together roots, the answer to this multiplication is the root of 4 times 2, which is 8. Now, the reason why we wanted to write the perfect square first is because we're actually going to solve that root. So the square root of 4 is 2. And then we tack on the root 2 with it. We don't write the multiplication sign anymore. It's enough that they're squished side by side together for us to understand that it's a multiply. So 2 root 2 is the simplest way of writing root 8. Let's look at another one. Okay, so root 125. That's going to require us to add a couple more to our list. So we'll add 121, which is 11 times 11. and then 144. Messily, but 144, which is 12 times 12. So if we could write out a list of factors of 125, yeah, you could do that, absolutely. Might be easier, though, to go to our list on this one. So where does 125 fit? Right in between our 121 and our incredibly messy 144. So then you work your way backwards, and you find the biggest one that's a factor of 125. 121? Absolutely not. Not a factor of 125. 100? Nope. Also not a factor of 125. 81? Nope. 64? Nope. 49? Nope. 36? Nope. 25? Ah, yes. 25 is a factor of 125. So we go back over, and we're going to rewrite 125 as 25 times 5. Remember, write that perfect square first. So that's the same as saying root 25 times root 5. And then we can actually solve the root 25. That works out to be 5, and then we have our root 5. So 125, written as simply as possible, is 5 root 5. All right, so let's look at some key points to remember about doing this. Key point number 1. Whatever other operation is going on, you must check your final answer to see if you can write that root simpler. Just like when you're working with fractions, you always check to see if you can write it in lower terms. You have to get into the habit of checking these root answers to make sure they cannot be written any simpler. Keep that list of perfect squares handy for this entire chapter. It's really good to have with you. Start where your number would fit on the list and work your way backwards and find the largest perfect square from the list. That's a factor of the number in question. You can use a calculator to check if you're not sure. And the last and final point, when you're writing out the factors, put the perfect square first, because that's the one that's going to get solved, and that's the one that's going to end up being the number in front of your final root. All right, that's it. That's all you need to know about simplifying radical terms.